This is the video for steady state routines. There's a routine here on the left and a routine on the right. Let's start on the left. It sets multiplier to 15 and then it divides it by 10, so it's going to be 1.5. Then it fills the 121 values at matrix with 0. Well, it's an 11 by 11 matrix, so it has 121 values, all of which here are set to 0, so it's a null matrix when it starts. Then it sets J to 1, K to 10, X to 3, and it has a condition where it could set it to 2, but we're going to have the one where it sets it to 3, so we're going to jump down here. Then it says it's going to divide the 3 by 100. So it's going to be 0.03. Then it says for I of 1, and down here we have next I 9, it's going to do the following. At first it's going to set matrix at offset K to that value in X. Well, that's 0.03. This offset K starts out at 10. So this is offset 10, and here we see the value, 0.03. But down here it says each time K is going to be changed or added, 11 will be added to K. So it means the next time around it's always going to be at offset right below the previous one. It's going to go down this column each time. Alright, so it sets the offset K to X, then it sets it offset J to 1, but then it subtracts the value that it already has at matrix plus K. So it sets it to 1, subtracts the 0.03, and gets 0.97. So here we see at the offset of J, which up here we see started at offset 1, so that's this position here, is the difference between 1 and the value here, so it's 0.97. When it comes down here, it's going to multiply X by the multiplier of 1.5 each time it goes around. So first this was 0.03, next it was 0.045, and each time it gets multiplied by 1.5. That's the value for X. So it adds 12 to J. Now that means it's not only going to go to the next row, but over one position. So we see that all those values that offset J are on 1 over from the diagonal. And it adds 11 to K. We saw that. That's putting it down 1 row each time over here. And then it goes around the 9 times. So those 9 rows all follow in that way. Then it says set the matrix value at 109 to 1. That's the one here. That indicates if you're ever in this state, you're going to always go to the last state. And it sets matrix value at 110 to 1. That's this value down here. So anytime you're in the last state, you're going to go always to the first state. Alright, this is the building of the transition matrix. Now the routine on the right. It says move the 121 values of matrix to hold matrix. Well, that's the 11 by 11 matrix. Then also move the 121 values of matrix to steady state. Then set NS to 1011. That indicates to this multiply list instruction down here that it's a square matrix 11 by 11. So you can, when you do this instruction down here, it's going to be a matrix multiplication of an 11 by 11 times an 11 by 11. Next, it checks to see how many iterations you're going to go. We're going to go around 32 iterations, so it's not less than 1, so it's going to drop down here. And it's going to say for I equals 1, down here next the iteration count, which we have as 32, one at a time. It's going to go around here 32 times. Each time it's going to do the following. It's going to multiply well, actually let's look at it this way. It's going to multiply matrix times the whole matrix every time it goes around. It puts it in the steady state, but the next line takes that steady state and moves it in the whole matrix. So every time it goes around, it's really multiplying the whole matrix by the matrix. And in our case, it's going to go around here 32 times. When it's done going around, it says, for I of 0 to next I 121, well, that's the number of values we have. It's going to take, say, if the steady state value is greater than small, the value, well, that small is just a very small number, go to be E. If it's not, make it 0. The reason for that is, if these values are so small, they should just be set to 0. That way this won't be such a cluttered matrix. But you see, it actually is a cluttered matrix anyway. Although you see most of the exponents, what are B's and C's? Yes, B's and there's some D's. All right. So it's just to make it an uncluttered matrix, but ours is cluttered anyway. So down here is that matrix, the one over here, multiplied by itself 32 times. And we're going to look at the last column here. It tells us that if we started out in the first row, we have a 0.14 probability of being in the last row. And all these are telling us what the probability of your being in any one of the rows that you're going to end up in the last row. Well, 0.14 is close. Well, no, wait. Yeah, 0.14 is close to 0.139. All these are close to 0.14, and down here also. So you could say the probability after 32 times the probability that you're going to be in the last row is 0.14. Alright, this is the end of the video on the steady state routines.